Question 6. Give the name, describe the faces and the number of vertices and edges. Now, you should recognize this as a 3D rectangle. 3D rectangles, we don't call them that. We call them cuboids. So this is obviously a cuboid, and we need to find the faces, the edges, and the vertices. Now, this is not a see-through shape, but we could sort of make it see-through to help us count the various things that are going on there. So if we were to draw a line here, and then another line here, and then a slanted line there, then we're sort of making that into a see-through cuboid, and it will help us count the faces, edges, and vertices. Now, I always say count the faces last because that's the harder one. The vertices is probably the easier one to do. Now, vertices is a posh word for corners. So you want the pointy bits, the corners of the shape. And you could put a blob on each corner. So there's one corner there, 2, 3, 4, 5, 6, 7. Now I'm pausing at 7 because had we not drawn those extra purple lines in, we might have just counted 7. But there's another one at the back and the bottom of the shape there, the cuboid. So that's going to be 8. But that's the one that we couldn't see without the shape being see-through. So vertices, there are 8 vertices. Edges are basically the lines that connect the vertices. So what we can do is go over those and keep a count as we go over them. We can get a different color, so I'm going to use green, and keep a count as we go over them. So we've got 1, 2, 3, 4 around the front of the shape, 5, 6, 7, 8 around the back of the shape, and you've got the one that connects the front to the back. So we're on 8. So we've got 9, 10, 11, 12. So that's 12 edges. 4 on the front, 4 on the back, and another 4 that connect the front to the back. So that's 12. And finally, the faces. Now, this is where you've got to think a little bit. It's a bit like a cereal box. So if this was a cereal box laid flat, then this could be the bottom of the box. This could be the top of the box. This would be the front of the box. This would be the back of the box. Then you've got the left-hand side and the right-hand side. So you've got tops opposite the bottom, fronts opposite the back, and left is opposite the right. This is why I've left the faces till last, because it's quite difficult to show that on a 3D drawn shape when it's drawn in the 2-dimensional way. So top and bottom, front and back, left and right, that's going to be 6 faces. So 6 faces, 12 edges, and 8 vertices.